Okay, let's have a class. I'm gonna going to slowly input the grade of exam 3 into the eCampus today. You should have received it by Thursday. Everything should be there. But I'm going to do right after this class. Something I would love to say is that we will at the end of the semester, there is still 5 classes to go, but you still have to keep doing the same job if you're doing really good. This is what happened is the people who is doing very good in the exam 1, exam 2, exam 3, and all of a sudden did not do very well in the final exam. That should not happen. So by all means said, if you're doing very well, please keep the same pace. Even if in the final exam you may only need 50 points to get an A, please study it normally and do not study at 50 points. Okay, just keep the same thing. We still have lectures, we have review sections, and plus we'll have a thesis writing of 30 points of the extra points. So we still have a lot of the up in the air for grab. So please keep doing the same thing. Okay, that's first remind all of you about that. If you're not doing very well, please also don't give up. There is a lot of there. Even if you cannot get an A, there is still quite an opportunity for you to get a B. Even your F right now, you still have an opportunity to get a C. So that's the same thing. So do not give up. Okay. Exam 4, we also call it a final exam, but it's not accumulated. Okay, so it's only the last section. We will talk about major 4 section material. Number 1 is food microbial safety. This is my research area, and we also call it applied microbiology. So food microbial safety. Then the second one we want to talk about is poultry processing microbial safety. Some of you working with Dr. Joe Motz, so you already know a lot of the food microbial safety of the poultry stuff and how the food poultry processing. And you also pre-vet student, you maybe already know some of the knowledge, but we're going to talk in detail about food processing microbial safety. Because in West Virginia, poultry is actually a big market, although it's come from a small processor. Then we will have one section talk about the basic immunology, including the B cell, T cell, and the vaccination, all those topics. Then the last section I'll talk about is virus, but briefly, because you have been heard about the virus in the last 3 years a lot from different resources. So usually I give at the end, I'll talk about that. Okay? Same thing, 100 points for the final exam, plus around like 10 points extra points, and 30 points will be a mini thesis writing. We will talk about this later on. Thursday, and I'm also going to put on the eCampus the topic of the essay. How you're going to have to prepare about that. You prepare that ahead of time, whatever you like, but in the exam room, handwriting 250 words, 300 words. Okay, it will be a debate question, so you have to prepare about that. Okay, so this is basically what we have left. So let's talk about introduction of food safety. I should say food microbial safety, because food safety including chemical safety also. If you look at the news, you saw it already. There is a Listeria monocytogenes with multi-states, cheese, dairy meats. 20 people died probably in 15 states. Then we will talk about Listeria monocytogenes today, okay? This is overall foodborne illness in the United States. There is a 2 recent survey, not really recent, it's about 10 years at least, but it's still the public available data to see the overall situation in the United States. The first one coming from CDC. In 1999, how many illness? 75 million. Illness per year. Hospitalizations 323,000. Cause deaths 5,200, cost $8.4 billion. Now, during the early 200s, there is a lot of the microbial intervention strategies applied in the food safety area. So, 10 years later, the survey you find that the illnesses dramatically decreased to 48 million. It's still a lot, but it decreased. Hospitalization more than half decreased. 128,000, deaths 3,000. Cost $1 million is dramatically increased, almost tenfold, is $77.7 billion. Because our medical technology is increased and the cost for the Medicare is increased. So that's why the cost is increased. So this is from the CDC data. Now, by the way, what is CDC? Centers for Disease and Control. Lots of people will say that. What is CDC? You heard about it every day. Centers for Disease Control. Is that correct? No. And prevention. Do not forget about this one. That is the full name for CDC, Centers for Disease Control and Prevention. Okay, you heard about this all the times because of new guidelines for COVID-19, for flu vaccine all the time. What is CDC? Centers for Disease Control and Prevention. Now, what are the foodborne pathogens we really care about? The very common one is a norovirus, actually. If you remember, about like 7 years ago in Yellowstone National Park, there is a small outbreak happens from the norovirus. People have diarrhea, nausea, vomiting, all those symptoms. But in here, especially in my lab, we are doing the research usually focus on the Campylobacter, Salmonella, that is for the poultry meat, E. coli 0157H7 and non-0157 Shigella toxin generated E. coli, which is called the STEC, is Shigella toxin generated E. coli. That means Shigella toxin generate E. coli. There is a lot of the E. coli. We have slides talk about that. Listeria monocytogenes, we will talk about this in a little bit detail. Clostridium botulinum, we already talked about. Infant botulism, food botulism, wood botulism. Related to the canning food, canned food. Shigella, we will mention about that, Toxoplasma gondii, and some of the emerging organisms. Now here's something I want to mention. Coronavirus, lots of the experts already said it is not a foodborne pathogen. Although there's a risk for the food supply chain, but it's not a foodborne pathogen. So the chance you get from the food to have a contaminated, infected with coronavirus is very low. It's very, very low. Because it's a virus, they need a host to survive. We will talk about that. Okay. This is several table tells you the situation. First of all, top 5 pathogens cause domestically acquired foodborne illness. What are they? Number 1 is norovirus. About 5 million every year. Second, Salmonella non-typhoid. What that means is non-typhi. Typhi, Salmonella typhi is a different story. That's related to the typhi marrow. We mentioned about that. Salmonella non-typhi, which means Salmonella Thompson, Newport, Hindenburg, all those relate to the poultry meats. Clostridium perfringens. We mentioned about the perfringens will cause gas gangrene, and we have to avoid the dangerous temperature zone, 40 to 140 degrees Fahrenheit. Campylobacter. And the last one, very surprisingly, it is Staphylococcus aureus. We did it in the first lab. But I want to tell you one thing, Staphylococcus aureus, usually they do not report to the CDC. It's very ironically, although it's a top 5 pathogen, domestically acquired foodborne illness. Top 5 pathogen cause hospitalization. Which one? is the first, is Salmonella. Almost 19,000 every year, followed by norovirus, close to 15,000, then Campylobacter, Toxoplasma gondii, and Shigella toxin generally E. coli. So somewhere is between 90,000 to 2,000. That's the top 5 pathogen cause hospitalization. Listeria is not there. And also very surprising, top 5 pathogens cause deaths. This is a tricky thing. This is the most severe scenario, will cause death. Number 1, Salmonella, 378, followed by Toxoplasma gondii. Do you know about that one? Parasite, which is in the cat, is that right? The cat is the host, is the middle host for the Toxoplasma gondii. Listeria monocytogenes, 255 every year. Norovirus and the Campylobacter. That's the top 5 cause death. Now, generally speaking, all kinds of food products could be contaminated with all types of foodborne pathogens. But we don't care about everything. We really have a focused group. What are the pathogens we really care? So fresh meat, what do we care? We can give you a table, okay? Fresh meat. If it is beef products, we care about E. coli, O157H7, and non-O157 Shigella toxin generally E. coli. If it's poultry meat, we care about Salmonella and Campylobacter. We will talk very detailed on Thursday about these 2 pathogens. So, but how about you say about pork? Well, Salmonella is the one, E. coli is the one, but not in a focus. Okay? How about rabbit then, people saying? In West Virginia, there's a local community doing the rabbit. Now, all of these are hot topic. So this is why these things are important. We listed here because they are involved in a national recognized outbreaks. Okay, Listeria monocytogenes is what they really care. Ready to eat meat. This is a typical one for Listeria monocytogenes. What are they? What are the ready-to-eat meat? Hot dog, frankfurters, sausage, salami even, turkey breast, ham. All those are vacuum packaged, refrigerated products in the supermarket, in the commercial market. Those are risk for Listeria monocytogenes. Several outbreaks in the early 2000s. Lost lots of people and a lot of economic loss. How about the fruits and the vegetables? Basically Salmonella and the E. coli O157H7, but Listeria is an emergent pathogen. Listeria monocytogenes in a ready-to-eat meat is a real, well-recognized risk. In poultry meat, it is an emergent pathogen in the fruits and the vegetables. It also is a we will say it's an under-researched pathogen because it's in the recent 20 years it's jumping. Traditionally for fruits and vegetables, Salmonella, E. coli O157H7. For example, tomato, we care about Salmonella. Lettuce, we care about E. coli O157H7. Okay, so let's say tomato. We care about Salmonella. And lettuce, we care about the E. coli O157H7. But of course, Salmonella could be on lettuce, but just not in the outbreaks yet. No, obviously norovirus. So let's talk about this a little bit. Listeria species, there is basically about things. But we care about is Listeria monocytogenes, and the second one, Listeria inocia. They're originally coming from soil. Listeria monocytogenes is a pathogen. Listeria inocia, I did a lot something in my lab, we call it a surrogate. What means a surrogate? they have to behave similar or even resistant to the antimicrobial interventions or thermal treatments compared to the target bacteria. So they have to behave resistant or equal to target pathogens. So for example, Listeria inocia is kind of a recognized surrogate for Listeria monocytogenes. However, in a different food products, we have to do a different validation study. Now, one surrogate is important because lots of the places we cannot use foodborne pathogen. We have to use is a low-risk surrogate. That's what it comes out, especially for the validation, okay? The picture you see here, what you see? Beta hemolytic on the blood agar. So it is very risk to lysis blood cell, and we'll see a transparent zone on blood agar, especially for Listeria monocytogenes. So what is that? It's a gram-positive bacteria. It's a very strong moving capability because it's a Petrotrichus flagella, surrounding the surface. It's a facultative anaerobe. What that means, remember, they can grow in the absence of oxygen, but grow well with oxygen. It's a hemolysin positive bacteria. It will cause lysis of hemocells. But there is one thing we have to mention, Listeria monocytogenes. This is a pathogen can grow very well in the refrigerated temperature. This is a huge risk because often the time we think I have a hot dogs, I'm going to vacuum package, I put in the refrigerator, is that safe? No, it's not safe. If they contaminate, they're going to start to grow. What we talk about does not mean all the Listeria monocytogenes we care about. There is about 13 serotypes we care about, and 95% of the foodborne pathogen coming from those three, 0.5A, 0.5B, and 4B. Especially the cerebral 4B is count for 65 to 80% of Listeria monocytogenes in the United States, in the North America, including Canada. Here is something we want to mention, the characteristics for Listeria monocytogenes. First of all, they grow very well in the normal bacteria media. TSB, YE, which means yeast extract, okay, at 37 degrees Celsius. Sometimes they will grow very well. We add vitamin B and amino acid. But the risk here is they can grow 10% salt. Remember, hot dogs, we don't like it. Ready to eat meat, if you eat it, very salty. Some of them at least 5% salt. And lots of the bacteria will be dying, but Listeria will survive there. What is the terminology for that? It's kind of a helper. They can survive up to 10% of the salt. That's why you only add salt. It's not going to solve the problem. It had a very wide range of the pH growth, 4.1 to 9.6, which is low acid to low alkaline environments, very high. Especially in this low acid environments, lots of the other bacteria could be dying, and this bacteria could be dominant. This is the key, the last one. They can grow 0.5 to 3 degrees Celsius. Cycrophiles. That's not good, because refrigerated, it will grow. And another thing, it can grow in a low water activity. Can grow as low as 0.9 to 0.92 water activity. What is the product have that low water activity? Summer sausage and salami. But Listeria can grow. What is the water activity of a hot dog? very high, 0.98 probably. So just want to let you know, Listeria monocytogenes can grow very well. Now, why it is a risk? This is what happened. In 1998 to 1999, Frankfurter's lunch meat. Frankfurter's is another name for hot dog. It's from Germany, you know that. 108 cases, 18 deaths, 4 stillbirths and miscarriage, 24 states. 2000 daily poultry meats, 29 cases, 7 deaths. Then 2002 again, 46 cases, 10 deaths. I want to tell you very honestly, foodborne outbreaks, nobody cares if you only have a diarrhea, vomiting, and nausea. Because most of them are self-limited. You're not going to transfer for the other people. But when they will care, is the people is died. Especially the kids are died. So, these couple of years outbreaks cost about $4.5 million lost in the industry. Accumulated about that, 40 people died, 35 people died. It's a risk. Therefore, in 2011, they did a survey. What they find? Oh, I should talk about this one first. Therefore, in 2003, regarding Listeria monocytogenes, come out with 3 alternatives. This is very important to control Listeria monocytogenes in a food products, in a ready-to-eat meat. This is called 3 alternatives. Listed by FDA and the USDA FSIS in 2003, right after the outbreaks. What are they? Post-lacellative treatments with antimicrobials. So what that means, you're going to have to well cook, is that right? Cook very well. You have a casing, you cook very well. Not only for that, because most of the Listeria monocytogenes is coming from is a post-processing cross-contamination. So what are we going to do? I'm going to using antimicrobials. Let's say sodium diacetate, potassium lactate, and sometimes lactic acid sometimes. This is the reason if you buy a hot dog, you look at the label. They will have some of these stuff there. They will have some of these antimicrobials there. Another thing you also can see, it's a purple color. Why? There is a sodium nitrite there for curing the meat. It's for the curing process. It's for the color, also for killing bacteria of Clostridium perfringens. Not really effective for Listeria monocytogenes, but just let you know. You can do these. You're required to do those. Okay, we gave you some flexible. You can do post-lacellative treatments or antimicrobials. Oh, sorry, by the way, post-lacellative treatments, which means some physical treatments, radiation or something, okay? Now you can use all at one of them. Because Listeria monocytogenes is coming from the environment, so there is something people say, I don't want to do anything. I want to do organic processing. Nothing for using antimicrobials. Can you do it? Yes. You have to do a good job of SSOP. Sanitation standard operation procedure, and very frequent testing. Microbial testing. But I want to tell you one thing, this is very tricky, because even you test, it does not mean test negative, does not mean your sample is all safe. There is a class 1, class 2, from standard deviation, class 1, class 2, standards for the testing. However, it doesn't work all the time. So, Lots of the time in the plants, they have to do multiple, or they have to combine with both of these. Okay? This is what comes out with FSIS, Food Safety Inspection Service, in 2003, have these three alternatives. But what it looks like after 8 years, if you do the survey, can you see it? In 2011, Listeria monocytogenes still is about 1,600 foodborne illness, 1,500 hospitalization, and 260 deaths. So it becomes better, but still a lot. That's annually in the United States. And recently, in the recent 5 years, people find that Listeria monocytogenes is on a fresh produce, is on the poultry meats, a raw poultry meat, not really ready to eat meat, and even in a ground beef. People already find it, it's everywhere. So we'll see what it goes. But I just want to tell you, it's a very big risk. What the risk it will has? Meningitis. It's one of the pathogens causes meningitis. For the pregnant woman, we not recommend them to eat daily meats because it will have a stillbirth baby and a miscarriage. So remember about that. Some of you guys there are dietetic internship, is that right? Dietitian. If you work future in the hospital, you do the training there. So new dietitian training for the pregnant woman, you should tell them for the daily meats, not recommended for a pregnant woman to eat it. Otherwise, you have to do the microwave or preheating. So that's something is important to remember. Okay, E. coli, what we're going to talk. We talk about E. coli from the beginning to the end, to right now. What we did in the lab, the E. coli is a generic E. coli. It's not really a big deal. There is a big group of E. coli. It's right there. ETEC. What are they? Enterotoxigenic E. coli. EPEC. Enteropathogenic E. coli. EHEC. Enterohemorrhagic E. coli. And EIEC, enteroinvasive E. coli. There's a lot. Plus urological E. coli. When we talk about E. coli, is the #1 pathogen cause urinary tract infection. But from the food safety standpoint, we worry about this guy. Enterohemorrhagic E. coli. Because it will cause hemorrhagic uremic syndrome, which is called HUS. Uremic syndrome. We will talk real quick. So, what is E. coli really? We find it. Long time ago, about 40 years ago, in Oregon and Michigan, the ground beef outbreaks, we find it's E. coli 0157H7. Then what is going to cause the problem? It's going to bloody diarrhea, water diarrhea, abdomen pain, and the kidney, I would say kidney degradation. It's a kidney infection caused hemorrhagic uremic syndrome, lead to the death 5% lethality rate. An adult thrombocytopenic puerperal. It's also beyond the kidneys. It's very invasive. Could go to the nerves and the neurological system. Now, why it is a big topic? Because of Shigella toxin. Shigella toxin has two, Shigella toxin 1 and Shigella toxin 2. We actually really care about this Shigella toxin 2. Why? Because in the kidney area, there is a very special place called the GB3. The GB3 will be attracting the Shigella toxin 2. They will be attached to each other. Will cause all the problem. And also don't forget, this Shigella toxin is also an AB toxin. The same thing like diphtheria. It is an AB toxin. Toxin domain and transmembrane domain, and very invasive. That's a risk. Okay? Because you can see here, hemorrhagic uremic syndrome usually caused by Shigella toxin 2. And the GB3, global triacylramide in the kidney area, is a target. And once they entering the toxin, will cause endocytosis and A unit is activated. So this is the Shigella toxin. That's why E. coli 0157H7 is a hot topic, is a risk. Because we talk about Shigella toxin, we comes out with a rapid testing method for E. coli 0157H7. In the lab, we can grow them in the media, then spread plating onto McConkey agar. If they're the pink colony, lactose fermentation positive, we say it's an E. coli. But in the commercial lab, we're not going to do that slow growing process. So they're using a PCR methods. If I ground the big products, they're using PCR methods to target Shigella toxin 2 and Shigella toxin 1. If they find either one of them or both of them are positive, these products highly likely is contaminated with E. coli 0157H7. The only thing we don't know is the 0157H7 is live or dead. Because molecular methods, regardless of died or live, they were all tested. Okay? So Shigella toxin is an AB toxin will cause a problem, hemorrhagic uremic syndrome. But from the rapid testing standpoints, they could use a PCR methods to test that. That's lots of the commercial kit is like that. But there is something we want to also continue. In 1982, there's outbreak already happened in Oregon and Michigan. We find it is HUS, but nobody really cares, to be honest. This happened. In 1993, Seattle Jack in Box. E. coli 0157H7 outbreak in an undercooked hamburger. Very unfortunately, 4 kids are eaten and died. They are less than 5 years old. This has really touched the nerve of the host country and even the White House. I worked in Seattle a year, in 2010. I worked in a company called the IEH Consulting Group. And the time when they started this testing, they developed a lot of the rapid testing methods for the E. coli 0157H7 because they're right there. And they're right in the Jack-in-Box in Seattle. You can look at how many people are hospitalized. 171. Majority of them 10 years old, less than 10 years old. 45 infected children, 38 severe kidney problems, 4 kids are directly died. So this is a big history. I can say it is a really tragedy. If you look at the news, they always say it's a big topic is hamburger killing kids, because the hamburger is not well cooked. So how we should cook it? USDA FSIS guidelines to completely destroy E. coli 0157H7. You need to cook to the internal temperature, 160 degrees Fahrenheit, 71.1 degrees Celsius. Here is something we want to mention. This is a beef steak. What they talk about, 160 degrees Fahrenheit and 71.1 is geometric center. This is not the surface. Okay, do you know the difference? On the surface, a frozen steak you put on the grill, a George Foreman double pan boil grill. 5 seconds, the surface becomes greenish. You think it's good? No. That's the internal temperature. So what they do, there is 2 methods to do. One of the methods in the lab is using a thermocouple to test whether they reach 71.1 degrees Celsius. Now, most of the time, we also a little bit higher than that. We maybe do 72. This is called critical limits This is called operational limits. We go up a little bit, lots of the time. But I want to tell you one thing, why there is a risk for that. Lots of the time, we cook directly from the semi-frozen status. So the frozen status, we cut it, we put in the grill, we do it. And lots of the time, people do not use a thermocouple. They're only to see how long it's going to cook. Maybe 5 minutes, maybe 10 minutes. But different products, their morphology are different. In one sample, you're using 5 minutes to reach 71.1 degrees Celsius for the internal temperature. In a second sample, if it's a thick one, if it's a large geometry center, a large one, if it's not evenly distributed as a meat, it may take a longer time, but people don't realize it. Now, the second question I want to say, people say, yes, cook to 71.1 is safe, but why there's still outbreaks happen? Because for beef products, we'll talk about juiciness, flavor, and tenderness. These are the three things. We talk about the meat quality. If you cook to 71.1 degrees Celsius, you cook to 75 degrees Celsius, what happened? The beef will become very tough, is that right? Not very juicy there, not much water there. How about tenderness? Of course, not tender. Because the trigger of the beef market is the tenderness. 90% of the people will pay extra $5 to buy a beef if it's more tender. Well, of course, that survey will be changed dramatically in recent days. That was 1996 people do the survey. Right now, it's dramatically changed because everything is expensive. But I just want to tell you one thing, people more care about is the tenderness. This is the reason when you go to order steaks in a steakhouse, are you going to order very well done? Most of the time not. You will say medium rare, is that right? It's a little bit pink. Obviously, you want to say, okay, I want a raw. It will be very raw, lots of the time. And this is, we talk about another thing, is called the dullness. That is about meat quality. So I teach in another class, which is for the chemistry. We talk about that detail, but here we just basically touched it. You have to cook to the internal temperature 71.1 degrees Celsius using a thermometer to test the internal geometric center. Another thing we also want to mention is the color, not necessarily is an indication. Lots of people say it's a gray, it's a pink, or it's ready to go. It really depends. If you cook in directly from frozen status, sometimes the greenish is not really helpful because the color is related to the myoglobin. And by the time the myoglobin directly becomes metamyoglobin, it becomes greenish anyway. So it really depends the status of the meat and also also how we do the packaging, how we do the storage. Okay, so there's lots of things we talk about. Another thing we also want to mention, it related to the fat components. The fat components is the key. So the beef, what we're going to do in the lab, 15% fat. That's okay. If you're doing 25% fat, then that's need a longer time to killing bacteria. And lots of the research showing high fat amount will protect the bacteria. Okay, so that's be careful. The fat components is important. So I just want to let you know there is lots of other ingredients, other factors will impact the survival of the pathogen in beef products. Also related to the juiciness, flavor, and the tenderness. So it is a mixed issue. It's not only one single item. So when this happens, what are we going to do when this happens? So by the time the White House, President Bill Clinton, Vice President Al Gore, with all the congressperson, they'll start to do something. So it come out with a new system. Not really new, by the time it's new, called HACCP. What is that? Hazard Analysis Critical Control Points. This is what we're going to spend in time to talk a little bit. You heard about this all the time. We talk about HACCP training. We have a products which is processed, certified with a HACCP regulation. What is that? HACCP. Hazard Analysis and Critical Control Points. This guy originally is coming from Fuse-Berry Company from NASA in 1959 because US Air Force go to the space. Remember, you go to the space, you have to make sure the food is safe. Is that right? If you have anything happen on the space, there's no way you can do. So, the system has already been introduced in 1959. But nobody really care about it until the Jack-in-Box outbreaks happens, they're required to do. So what is that really? Number one, conduct hazard analysis. What is the hazard we really talk about? Biological, chemical, and physical. Here in this class, talk about bacteria is a biological hazard, so conduct a hazard analysis. Okay. What else? Establish a critical control points. So what is critical control points? A step at which during the food processing, something we can do to reduce the food safety risk to an acceptable level based on the regulations. What is the area of the concern? Presence of pathogens, heavy metals, toxins, physical hazards, type of the treatments, ingredients received. This needs to do is a flow chart first, and assembling the HACCP team. What are they? Focus on these critical control points. We need to establish a critical limits. What is critical limits? This is a physical, chemical parameters to make sure the critical control points is met. So, for example, 71.1 degrees Celsius internal temperature is a critical limit. pH equals 4.0 is a critical limit for low acid food. But be careful, these critical limits cannot be a range. Which means I can say cook to 65 to 71.1 degrees Celsius. This is not acceptable. Under HACCP plan, this is not acceptable. Under the brand new Food Safety Modernization Act plan, it might be, but there's a debate about it. So establish critical limits. Number 4, establish monitoring procedures. Monitoring procedures. Make sure these are monitored. So what do it mean? You're going to say, I cooked to 71.1 degrees Celsius. I need to see how you make sure it's good. Your thermometer is good, it's calibrated. You said the pH 4.0 for canned food. How do you know it is good? Your pH meter is calibrated. So basically, this is calibration. Just an example, okay? Of course, different food is different. Okay, if anything happens, anything wrong happens, we call it a deviation. Conduct corrective actions. Which means we have to do it immediately. If you have a food products, it not reach 71.1 degrees Celsius, what are we going to do? That products cannot go to the market. You may have to recook. Is that right? That products If they go to the market, they finally find outbreaks, find the contamination, you have to recall. Remember, there's 3 types of recall. Number 1 is pathogen. Number 2 is allergy. Number 3 is mislabel. So that's going to be a tedious work for a company. So corrective actions is important. If the deviation happens, you need to have to do it. I will give you a very easy example. Ground beef is 0 tolerance for E. coli OM57H7. You cannot find one cell there. Otherwise, we call it adulterant. So lots of the company, when they do the testing, they find that there is an E. coli OM57H7 there. So they have to do corrective actions. Because for the ground beef, it's difficult to control. The only the critical limits, critical control points, is a refrigerated storage at 5 degrees Celsius. If you find the E. coli OM57H7, how are you going to do corrective actions? Well cooked to ready to eat meat. Then become what? Hot dog. So that's why I tell you a secret. About 50% or 60% of the commercialized hot dogs, they are coming from those contaminated ground beef because they're well cooked and it is allowed legally to do it. So that's one of the examples for corrective actions, okay? I have a critical control points. I have a critical limits. I have a monitoring procedures. I have a corrective actions. How do you know it is good? So for example, I have the 71.1 degrees Celsius for a cooked beef. Say it's safe to curing all the E. coli OM57H7. How do we know about it? We need to do validation and verification procedure. This is important. Validation, you could do is an internal team. A small company, they have a team to do it. A large company, they have a team to do it. And small companies, they usually use a third-party service from the service for the testing company to do it. This is validation. We need to make sure 71.1 is killing bacteria. So how we do it? So this beef products, we're going to inoculate the bacteria, E. coli OM57H7. Okay, we're going to cook in the grill. We need to cook to internal